Good afternoon, everybody. A warm welcome to a lecture session by Dr. Rajesh Kumble Nayak, a very eminent speaker from Indian Institute of Science, Education and Research, Kolkata. He will be speaking on a hotly contested, debated, and researched topic, alien life. The scientists all over the world are working on it, and every day, practically every day, new fields are opened up, new exoplanets are discovered, the traces of water is discovered in our solar system as well as in the exoplanet, and lots of information are regularly coming to us via newspapers, YouTubes, and everywhere. To acquaint the people of Kolkata, the people of West Bengal and India who are watching with us, we shall be now introducing Professor Nayak, and this introduction will be done by Sri V.S. Ramachandran, the Director, Birla Industrial and Technological Museum. Mr. Ramachandran, please.
Good evening, viewers. Very happy to have a talk on alien life, which is a really exciting one, by Professor Rajesh Kumble Nayak. Birla Industrial and Technological Museum is organizing this talk in association with the Bhawanipur Education Society College. And I would like to give a brief introduction about the distinguished speaker, Professor Rajesh Kumble Nayak, who is very well associated with the Birla Museum for a long time. Professor Kumble Nayak did his PhD from St. Aloysius College, Bangalore, Karnataka, and he did MSc Physics at IIT Madras. Then PhD he completed in the prestigious Indian Institute of Astrophysics, Bangalore. In his glittering career, he was associated with many elite institutions. Some of them only I am going to tell. One is the Department of Physics, Astronomy, University of Texas, and Brownsville. Then he was involved in observatories at Nice, France. Then he is also involved in IUCA Pune, a prestigious institution. Right now, he is working in Indian Institute of Science, Education and Research, Kolkata. He is in the Department of Physical Science, Center of Excellence in Space Science. His field of interest is very interesting: gravitational waves, data analysis, general theory of relativity, and astrophysics. And he enjoys working in mathematical and computational physics. So, with these few words, I would like to leave the forum open to the distinguished speaker, Professor Rajesh Kumble Nayak. Welcome, sir.
Okay, thank you, and for nice introduction. So first, I should warn you that I am no expert on searching alien life, but it is an interesting topic from astrophysics perspective. We are all interested in searching for life elsewhere, and also from the humanity perspective, one is always interested in the life for extraterrestrial life. So I am going to give this talk just as a non-expert. I will try to stick to the facts, not to fantasy, because searching for extraterrestrial life always has been in the borderline between science fiction and reality. So we have a detailed observation done from the various perspective telescopes and other things. There are also, of course, there are fictitious corners for everything. So let me start with the this thing. What are aliens? So the aliens essentially considered as a people with the green color, because this is somehow become very popular that the extraterrestrial life with the green color. But however, from the definition perspective, it is considered as a hypothetical or fictitious. See, both comes into fiction, but we are not worried too much about fiction, and which is essentially coming from the outer world or the world elsewhere from our Earth. So that is what we call as alien life. Now, the interesting point here is that the human curiosity is a critical factor. When we are always interested in knowing what happens outside our own domain, or we are always keen to know what is out there. Are there life forms similar to us or dissimilar to us? What is it doing out there? Are they going to cause harm to us, or we can exploit them? These are some of the human nature which is coming out in terms of curiosity. Also, ignorance and fear also leads to a lot of this. I'll briefly turn the clock to a couple of hundred years back. At that time, Earth itself was not explored very well. This is, for example, is a map of Earth which is known. Major continents were known, but there were always places which were unexplored, and which led to human curiosity as well as various fantasies which involve thinking of the life form of different shapes and sizes. So, for example, we have this beautiful novel in which human forms, which are either tiny or too large, but nonetheless they are in the form of human shape. So, if you look at the Gulliver's Travel, this map is essentially unexplored. That means we did not know. Now, this is the main factor. Ignorance with the curiosity, fear, and fantasy combined together led to all this novel. But as a astrophysicist, we try to ignore this aspect of human curiosity or fantasy and collect as much data as we can and explore a real possibility of having life elsewhere. Of course, now life on this blue planet is more or less explored. It is not that we are not discovering new species. We are also discovering new species, but that is not something very unexpected. There are something maybe deep in the ocean, maybe some in the deeper areas of the land itself. You could have something which is not known earlier. But what we are interested to have search for life which is more robust, as we understand on Earth, which we believe that we have more or less explored based on the space and other consideration. Every nook and corner of Earth now can be observed using satellites and other instruments. So the attention naturally goes to searching for a life elsewhere. So knowingly or unknowingly, astronomers become the part of this search, and you see that telescope becomes one of the most important device for looking the life beyond Earth. Now, it is not the technology itself which has led to the curiosity to search life elsewhere. We have two neighboring planets. One is Venus and other is Mars. For a long time, we knew Venus was thickly covered with the atmosphere. Venus atmosphere is about 90 to 100 times heavier than the Earth atmosphere. So there is enormous pressure. And from Earth-based observation using telescopes and things like that, you could not reach to the surface of Venus. So somehow most of the search for life outside, or a hunt for life, was mostly confined to Mars. Mars was a major hunting ground. Adding fuel to it, you all might know that the Mars also has this polar cap, and season to season it melts, and it does not necessarily need to be water-based ice. It could be something which is other liquid, could be frozen and forming. So what astronomers observed in early 1890s, they observed series of canals on Mars using a telescope, or Earth-based observation, and this led to belief that there could be life form on Mars, which is far more evolved than Earth, which could do canals on the planet-size canals, and transform water from one region to another region. Now the detailed observations were made, and you can see that this is basically a misunderstanding. These are canals which meant to be canali. In the when it is translated to English, it becomes canals, and to suggest that it is basically a man-made canals for transporting water. And this kind of misinterpretation and misunderstanding has a lot of scope when it comes to searching of extraterrestrial life. It is not to say people are careless. It is just the enthusiasm to figure life elsewhere. But many observations eventually led to believe that there is nothing on Mars. But we'll come to Mars a little later, because red planet has been explored in detail, much more than any other detail. So we have a lot of interesting result from that. But let's have a global scenario of how to search for extraterrestrial life in the evolved form or not. So let's see, how do we search for life? This is a basic question. Is there a scientific method by which one can concretely say that these are the signatures of life? Now, when we say life, it don't have to be life of form in our own form. It could be primitive form, it could be a single cell based life, or it could be any other form which we have, or it could be simply a green alien. It could be anything. But as we understand life from our own planet, we see that there are three important ingredients goes into life. One is carbon-based molecules, liquid water, and energy source. We believe that energy sources are stars, and then we believe that there are plenty of carbon-based molecules. So water turns out to be one of the critical factors. So if we want to search for life, we essentially have to search for water. Water on the Earth is one of the essential for the sustenance of life. We see that including older civilizations were built on the closer to water sources. That is to have a larger scale civilization. But even primitive life seems to be supported by water. If you don't have water, there is almost no life. So water is essential, and to follow the water is to find the life. So this is a simple principle. If you are lost on the planet, say a desert or someplace, you find the trickling water and follow it, and you find the civilization. So it's the same way you associate life. You even associate formation of life on Earth with water, because there are many theories which say the formation of life on Earth, and water is essentially part of the most of these theories. So water is an essential ingredient for the formation of life, and life water could be simply in the form of ice too. So we go to search for life. In this lighter note, we see that the alien could be knowing us far more better than we knowing them. So they are also very cautious that they say that as long as we find water, they are fun. Otherwise, there's going to be a big trouble, because people seems to be going after more interesting things than water. Another thing is the atmosphere. Atmosphere plays a much important role on our Earth, and it is easier to find out the content of atmosphere. For example, as a living signature, we are releasing various type of gases. These gases could be symbol of our civilization, or symbol of our progress, what we call greenhouse gases. If one can trace these greenhouse gases in the atmosphere of the planets, then that is a much easier way of figuring out the signature of life. Why? Because astronomers have this very interesting method which is called the spectroscopy. You know that when the sunlight is passed through, the white light is passed through the prism, it broken into various colors. And in the molecular form, various gases absorbs various colors. They are very sharp line characteristic of individual element. And when you see the sun spectra, you see absorption line corresponding to the chemicals present in the solar atmosphere. If it is passing through the Earth atmosphere, you can also trace the various content of Earth atmosphere. So this leads to identification of the material in an atmosphere of a planet, which can be done using a spectroscopy or absorption lines. With this, we can identify the chemical content of atmosphere and look for the signature of the living or civilization or trace of life. So this is the basic methods. Look for water, look for a place where people can live, and then take the spectroscopy. It's easier said than done, but these are the basic techniques one need to follow. Let's look at our own solar system. For a while, let's ignore this smaller planet, Venus, Earth, and Mars. Let's look at the outer planet. There are some interesting cases here. So we have Jupiter, Saturn, and all these major planets, which are essentially gaseous. So they are made from gas, which we believe that it is not suitable for sustaining stable life. So these are, it is practically impossible to live an evolved life on that. There might be a primitive life, but even then that could not go much further. Of course, people who are looking for life do not give up. They find that all these major planets have an enormous number of moons or satellites, and some of them are could be as big as Earth or Moon, and then they could have a solid surfaces. And many of them have seen many of these planets are identified either with the ice or the liquid oceans on them, or solid ice on them. So one can easily trace this. Life not might have it might be harsh condition to live, but the life, when it is convenient, it flourishes even in the harsher atmosphere. So we have many cases in our own solar system which have been studied by the satellites which are sent to explore the outer planet. These include Voyager and many such things. They have studied these things very carefully, but there are limitations one which can study by approaching this, unless like Mars and other thing where we have already landed and explored. These are tiny signatures of life is very difficult to make out for this. But there has been a lot of exploratory work for looking for water, looking for ice, and looking for ocean structures underneath the ice to identify possibility of organic life, not necessarily fully evolved in these planets which I have marked, some of them around the Jupiter, some of them around the Saturn, and the furthest one is called the Triton, which is one of the moons of the Neptune. So these are the possibilities of extraterrestrial life in our own solar system. Now, to signify the difficulty involved, how difficult it is to explore this planet, and this might be well familiar photograph. This is called the pale blue dot. If you can identify this blue dot here, this is a planet Earth. This is all the life or sophisticated life which we know as of now is purely in this dot. This is a picture taken by Voyager in 1990s, inspired by the science fiction writer Carl Sagan, who said that it would be good to have this picture to show humanity that how vast the universe is and how insignificant all we talk about ourselves is just nothing more than a dot. Now, this is taken from 3.7 billion miles or 6 billion kilometers, slightly twice the distance from the Saturn. Saturn is about 3 million kilometers, and then you see that we are no more than a dot. Now, in the same way, when we are looking for the planet elsewhere to study the form of life, you see that this would be worse than a dot. That is what the difficulty is all about. To figure out the extra terrestrial life or life elsewhere, it is extremely hard because even at the closest distance as a 6 million kilometer, the all life we know is no more than a just blue dot. And one has to figure out whether life exists on this by using various methods, which I have already told. One can use such things, but one need sophisticated equipments and identify the life on Earth. So that is where the more recent development comes. What if we look for life in our solar system and we are more or less happy that the conditions are not as suitable as we find on Earth? The possibility of having a life elsewhere is comes with that we have a sun is just an ordinary star. It is not even a very significant star. It is called the yellow star. And in our own galaxy, there are about 10 to the power 11 such stars. And the closest one is about 3 to 4 light years. And light year is about 10 into 10 to the power 12 kilometers. And you can have them in various units. It is a distance traveled by the light in a year. So if you want to communicate to any of these, it is about 3 to 4 years it takes one-way trip by the light alone. Now our Voyager has crossed the solar system, but it is unlikely that it would reach any of meaningful destination. So one has to search using other techniques for extra solar planet or the planet belonging to other stars. Last 20, 30 years, this field has become very active, and we even had a Nobel Prize awarded a couple of years back for the first person who developed the technique for detecting the extrasolar planets. So this is one of the examples. You can see again a star which is similar to Sun will have planets which are identified. This star is about 51 light years. So it is pretty far away from us. Light itself takes about 50 years to reach. And then you can see that these planets which are discovered will have a size roughly of the scale of Jupiter. So you can see them as the size of Jupiter, and the Earth is about 1,000 times smaller than the Jupiter, and comparison it is given. The finding of the extraterrestrial planets or exoplanet is extremely difficult task. So the special techniques have to be involved, and that is what we in the NASA 2009 launched a special telescope called the Kepler telescope for exploring the extra solar planet or exoplanet. So this is a dedicated telescope, especially looking for the planet elsewhere. So one of the main difficulty in the looking for the exoplanet or this thing is that the brightness of the star. You can see that the planets themselves don't have any light. They don't emit any their own light. They essentially reflect light from the sun or star. So if you have to see a star which is very bright and reflected light from the stars coming from the planet is what need to be detected, which is very, very small compared to the star's light. Now, this is the same question you are asking, why you cannot see the moon during the daytime. The moon, even if it is present during the daytime, it reflects the solar light, but sun itself is so bright, and in that contrast, you do not see the moon. That is why you do not see the moon in the daytime. You can see sometime, maybe in the afternoon or when the atmosphere is very clear, there are no scattered light, you may be able to see the moon also during the daytime, but it is very, very difficult to see moon in the, say, let's say 12 o'clock in the afternoon. The same problem happens when a planet passes, when we are watching from the Earth, when a planet passes through, a tiny amount of light is absorbed, and then when it crosses across the star, it comes back. The amount of light absorbed by the planet itself is very, very small. It is about 1 in 1,000, or you can see the plot here. It is called light curve. As the planet moves and it comes obstruct the stars from sun, the intensity or brightness goes from 99 to 100 to 99.9. So that is the level of light. So you need a special devices to see this contrast, and that is what they call which was built on the Kepler, which can see the brightest object and dullest object one part in 1 million. So that is kind of contrast you have. You can have a try this experiment with your mobile phones. You can take picture against a dark background and your foreground doesn't come, because your mobile cameras are not capable of giving a contrast of very bright and very dark. It ignores one of them, usually the dark one. So the CCD or the camera in Kepler, which is capable of having a 1 million difference between the, or 20 million difference between the brightest and darkest point, and it figured out, we already know about 4 or 5 thousands of extrasolar planet, and some of them or many of them, for example, on the scale of Earth size. You can see here, this is the Earth size, and this is the orbital period around the stars. Many of them around the size of Earth. Then you have a size of Neptune and Jupiter. So this is essentially what you have, our understanding of extrasolar planet. About 5 to 6,000 of them are already known, and more of them are explored. Now the important question is, are these planets inhabitable? Can human being or the life similar to human can exist there? So this is the fundamental questions which is there. So in addition to what we have seen about the water, air, and so on, planet also need to be rocky planets. The extrasolar planet which we are searching for is biased towards the Jupiter-like object, because they are essentially looking for light blocked by these planets. As the planet becomes smaller and smaller, it becomes difficult to do these studies. The bigger planets are easily detectable. That is why we are biased. We tend to detect more of the Jupiter-size object than the smaller than Earth-size object. So we need Jupiter type planets are not really suitable for sustaining life. So we see that we need something Earth-like, where there are rocks present, where life can grow and sustain. So that is what one should look for, and that is what extrasolar planets people are also looking for. And they have found this is a constellation Cassiopeia on the north side of northern side. So we have a star there called the HD 219134 marked in circle. So this star has a planet which is now confirmed to be having a solid rock. So that means it is an Earth-like planet rather than the Jupiter-like planet, where you have a solid surface where life can sustain itself and grow. So this is a kind of a planet which we are interested to explore. So I already told our planets are, our method is biased to look for the planet of a Jupiter size. That is not discouraging. In the solar system itself, I have earlier showed that the Jupiter-like system or Saturn-like system has a number of moons which have a solid surfaces. Even they are good candidate for search for life in our own solar system. Similarly, we can have moons on the planets around the extrasolar systems, and then we can look for these moons on the bigger planets, and that increase. You can have Earth-like moons to Jupiter-like planet, where you have water and fully sustained life. This increases the probability of or possibility of life in a given system, because Jupiter-like or Saturn-like system can have an enormous number of moons, and many of them are good candidate for sustaining life. So that is where we are increasing the probability of a search. You are looking for the planet, and you can looking for the moons around the planet which support life. Because it's an idea, but it is very, very hard to look for the moons. You already know that it is already hard to figure out the existence of planets around the stars, and then you are going one order lower. You are looking for the moons around the planet at a very large distance. Roughly, to get the idea of the scales here, to search for the planet on a star is like identifying a cricket ball on the moon. Now that is approximately the size. To give you idea even further, you have recently heard all about this lunar mission, Vikram lander and so on. Vikram lander is about 1 meter size, okay? And you are looking from the satellites which are about 100 kilometers from the moon, and still you are not able to identify them with properly. That means the size of scale you can identify on moon based on the satellite going around the moon 100 kilometer up is about 1 kilometer size. Now I am talking to ask you to see a ball about 5 centimeter or 10 centimeter diameter from Earth. So that is the difficulty you have identifying these. But the mission like Kepler is designed to do that, and they have figured out. Now we are going further to have a more detailed investigation to look for sustained life. Atmosphere. Atmosphere is an important concept, and it is much easier to figure out the content of atmosphere, because spectroscopic studies are much easier done than the rest of the things. So that is, you take the rainbow of the planet, or you take the study of spectra. When you have a star, it has a certain spectra. When the planet comes in between, and if the planet has an atmosphere, the absorption line of the light coming from this to us, because of the presence of the planet and its own atmosphere, get modified. Because of the content of the atmosphere, whatever molecule present there will absorb more light and putting their signature on the spectra, and we can identify them. For example, we can identify the water molecules, we can identify the ozone, we can identify carbon dioxide and water by looking at them. This could be in the visible line, this could be in the radio or other electromagnetic spectrum. So one can also look for the molecular lines, which are much more complicated. Each gaseous molecule have their own spectrum, and one can identify them using the stellar spectrum with the planets around them. As the planet pass, they imprint their signature on this spectrum. So that is one way to identify the possibility of various content of this. Now we understand the water is a most significant factor to sustain life, as we understand the life from Earth. There could be other possibilities, but we know that for definite that if life like on Earth should be there, there should be water. So Hubble also has found out the trace of water first time in year 2015. Planet was it is K218b is the name of the system. They found the water vapor trace on this planet by looking at the spectra of the star. So this is one of the most significant step forward looking for extraterrestrial life, because now you have a signature of a water present in the planet elsewhere, and this can signifies the presence of life, or the possibility of supporting life on the planet outside the solar system. Now there are more conditions which we call is a Goldilocks zone. This is a fairy tale which we all have studied. This Goldilocks goes into a place where three bears live, and you find a porridge which is too hot and too cold and just right, and then you have a bed which is too hot and too big, too small, and just right. The life is also in a same way. If the planet is very close to a star, then it is too hot, and it is difficult to sustain life. In such case, we know, for example, Mercury is too hot, it's too close to sun. On the other hand, the planets such as Jupiter, Saturn, and so on, they are too cold, even ice becomes solid. We need the flowing water, or rather water in liquid form, to sustain life. That is a machinery which should work, biological machinery should work based on the this system. So this is where you have around Earth, the conditions are light, it gets enough light, it gets enough radiation from sun to have a sustain a life. So we have this zone around the star, which is called Goldilocks zone, where the conditions are just right enough to sustain a life. So in our solar system, we have Venus, Earth, and Mars in the Goldilocks zone. Now, one way to look for the extraterrestrial life is to map all known extrasolar planets into Goldilocks zone. If they are in Goldilocks zone, there are better chance of sustaining life. That means you have to calculate the radiation received from the star to the planet, and the various heat which it receives. So there has to be a balance between them, and the life should be supported based on how far it is from the store. You can have divide the known planets into habitable zone or Goldilocks zone, and the planet which are most likely to have, like Earth-like planet, where conditions are even favorable. We have three planets in our solar system in the Goldilocks zone, but we know that the Earth is different from other two. So that possibility also one can consider and classify planets further to have a better sustenance of life and look more carefully these planets. Look for intelligent life. Of course, there are various philosophical perspective of intelligence, and you can see in this cartoon Kelvin and Hobbes. You can see that sometime I think that the surest sign that the intelligent life exists elsewhere in the universe is that none of them have tried to contact us. So they already know that we are not good enough to contact. Of course, this is a perspective. So other thing is that if there is an evolved life or intelligent aliens present in one of the favorable conditions, like Earth in the Goldilocks zone, maybe they are a bit hesitant to contact us, but we could contact them. So we could broadcast our existence. For example, Voyager has been encoded with the solid plates details about human race, but it is unlikely that the Voyager would be picked up by one of the intelligent aliens. So other way is to send them signal or try to tap their signals. So you could simply send the message that we are here and come in, and of course there might be scared, and there might be various other side effects, but nonetheless we can either broadcast our presence or we could receive their message. So this is a basic philosophy between search for extraterrestrial intelligence or SETI. It is not a fiction or anything like that. It is well-funded scientific projects where people seriously work on tapping the signal sent by either means of radio signals. Radio is a most favorable band because you believe that if the life elsewhere is intelligent enough, then they should be having a communication system using the radio waves. So we could use our system to transmit the signal, or we could search for signal from well-known planets or known possible places where the life exists. So these are very serious effect. A lot of money has been gone in. There is a breakthrough. Listen is a most recent of this study, where you have a radio telescope looking for the signal coming from the extraterrestrial life, and none of them have actually have made any significant progress in terms of receiving signal, but they are seriously looking for signals coming from this. With modern technology, you can go one step ahead. Nowadays, you have a better telescope. You can look for the signature, such as other than the radio signal. You can look for the light. You can look for the atmospheric content, greenhouse gases, and many such things, including megastructure. Some time back, there was news made that the people have discovered a planet or a star with the megastructure around it. But these are not sustained things. One has to be careful verifying such things. But we are in a positive direction, going to looking for megastructures. What could be the imprint of civilization, especially the atmospheric contents, which are well within our reach to identify and figure out. Polluting gas, for example, a civilization which is evolved would be producing enough greenhouse gases, and those can be traced. Now let's come back to, we have gone around the solar from our system and to various planets, and come back to solar system. We have two more planets, Mars and Venus, in the Goldilocks zone. So it would be interesting to catch up with this. With the modern technology, there is a significant change in the effort towards looking for life on these two planets. Now, on the Mars, several rovers have been already landed. They have examined. Now, this image by NASA, which shows how the detailed studies have been done. You actually can drill on the Mars, take the content out, sew and throw out the unwanted products, and analyze the useful fine grains and measure the content, look for the microscopic life. So this is a level of search which has been done last few years, and you can see that this is unwanted stuff. This is thrown out after analysis. This is the drill hole where you can deeper into surface, because one of the belief was that the Mars had a life earlier and possibly could have a water below surface, and then there might be a primitive life form still surviving on the Mars, and one want to detect them. The curiosity was looking for the microbial life, and there is enough evidence that such life could exist. Now, there are more and more evidence of water on Earth. In a year, 2 years back, NASA reported that there could be water on the Mars. There are some region close to the southern pole of Mars with the extent of about 20 kilometers, like craters, which could have water either in the ice form or in the ice form as a lake. So this is 2-year-old, and in this water body, you could have a microbial life which could be evolving on their own. Now, this is ongoing studies. This is a very new news. This is about a couple of days back. Again, NASA has announced that it has found about 3 lakes under surface lake near the South Pole. And these could have buried with the saline water near close to South Pole again. These lakes could have a hypersaline solutions of water with various salts and chemicals, calcium, magnesium, sodium, and potassium, and life could be present. We know the microbial life can be sustained under such condition, even on the Earth, under the volcanic condition and so on. As long as water is there, there is a sustained life. This is a map which is produced based on the radio or the microwave measurement. So it cannot really tell the content of the chemical content of the liquid which is present. So this is approximately the structure. This is the latest news. It is just 2-3 days old, and you might have read it on the newspaper. This is considered to be another significant step forward in the direction of finding out the microbial life elsewhere in the solar system. Of course, Venus is not too far behind in this age. People have looking for Venus for a very long time, but this is the recent news about a couple of weeks back. People from UK have found Astronomical Society has had a very detailed news coverage which says they found a chemical called phosphine on the uh, Venus surface. This phosphine is a stinky or smelly substance which don't seems to have any geological way of producing. That means to produce phosphine, you have to have a biological way of producing. That means there could be microbials which have to produce this phosphine. And if you find the phosphine, it implies the presence of microbial life. But on the other hand, well, it is not so sure, but you have found a way that to describe or which leads to possibility of detecting microbial life on the Venus. This is a far more interesting news in the last couple of months. If you look at that, we have two significant news. One is liquid water on Mars and finding the phosphine on the Venus. This clearly shows that the possibility of microbial life in both these planets which are present in the Goldilocks zone. But where life is more favorable, it is growing in a much more evolved fashion on the planet like Earth. The bacteria which can produce phosphine can live in a very extreme condition. On Earth, they could be found in the case of where you have volcanoes. They can absorb the heat energy from volcano and survive in the extreme condition. Again, some details. Phosphine was discovered by observing their absorption lines, and this has been very detailed study and showing that phosphine lines are present in the Venus atmosphere. So again, it is a mystery whether these bacteria are present in the atmosphere. How did this gas come to upper atmosphere and so on? Nonetheless, it is clear signature that there is a phosphine present and the possibility of microbial life similar to the geysers on the Earth were volcanic heat sustaining the life with their energy and producing interesting colors to the thing. Maybe do I have a few more minutes to complete a last one slide? No response. Okay. Hubble has done significant discovery when it comes to presence of extraterrestrial life. So it has been 30 years since Hubble has been working hard. So there is a saying that we should look at the life on Earth more carefully than looking for elsewhere. So let's have a quick look at the life on Earth. Everything plotted on a 24 hours, okay, from star formation of Earth to our present age. You see that how various conditions have evolved, and we have had a microbial life, then algae, more complex life, jellyfish, and so on. And when it is 11:58, we have started from zero, and when it 11:58, just about 2 minutes before now, we have had a human life, that is evolved life. This is to put everything in perspective. Evolved life may be a short glimpse in a large scale of time on a planet or the planetary system or the star's life. But nevertheless, what is important to see is that once the conditions are favorable for life, it flourishes. It need not be evolved form in the human form, but it exists. Even human race may go, maybe many more things. We have seen the series of evolution on life where the destructions have happened because of the various reasons and so on. Dinosaurs and all, many species have extinct. But nevertheless, when conditions are right, life flourishes. This is what we have seen. So same question is to ask is whether life could be was there or could come on our neighboring planets. That is the question, and that is a mystery which we need to resolve before we say how life could be sustained. But in search for extraterrestrial life, we are heading in the right direction, looking at the various facts and figures, not based on the fiction. Okay, thank you. Maybe I took a few more minutes, but well, anyway, uh, I will stop here. And there are some questions. Maybe I could take it.
Uh, Thank you, Professor Kumble. We have two or three questions, though they are not very relevant to the topic. Uh, I can put it to you if you think they are fit enough. You can answer them. One comes
Yeah.
from Varsha Shah. Uh, she asked, uh, "Can our weight change when we move closer to the Earth core?" Am I audible,
Okay.
sir?
Yes. Yes. Okay. So weight is a concept, is a force attracted towards the gravity. So if you have a mass m, then the force acting is a mg. So that is basically the weight. So weight depends on the acceleration due to gravity. So if you are on the surface of Earth, then we know that the acceleration due to gravity is about 10 meter per second square. Now, if you go to Moon, which is about 1/6 size of Earth, then its gravity, no, once size may be different, but its overall gravity is a 1/6 time of gravity of Earth. That means it has become smaller, its size is smaller, and so on. So this is a practical answer to your question. If we peel off some of the mass of Earth from the top and reduce it to size of Moon, then our gravity would be reduced. You would feel less heavier. So this is also important from the perspective of evolving life. Suppose you are on a Jupiter. Jupiter is 1,000 times. Gravity is extremely high. You will not be able to move, and you have to spend a huge energy to move from one place to another place if there is a level up and down. But on the same level, you can move. So it is difficult to have. So size of the system, depending on the density, your mass would be, or the force acting on you to retain you up, or would change. So you go to closer to the core of Earth, your mass would be naturally not mass. Your mass would remain same, but your weight would go down because Earth is attract you less.
Thank
Yeah,
you.
so it has a, one of the factor for life is the gravity. So that is why we are also keen looking for the system with the Earth size. Okay.
Yeah. The next question comes. It's a highly hypothetical one. Sajid
Okay.
Khan. He asked, "Is there any parallel universe?"
Okay. Is there any parallel universe? Maybe there could be, but unless we know how to study them or contact them, they are as good as not there, right? So if we can contact them, then you may not want to call them a parallel universe, right? They are part of our own universe. So this is again mystery which people are bringing in to solve some of the problem in cosmology. But practical stand is like this: if they are there and if you can't communicate with them, they are as good as not there to you. And if you can communicate to them, they are as good as part of your own universe. So we really don't need that concept. Of course, some mathematical model require that, but that I don't want to discuss here. it is a part of more complicated mathematical discussion.
The next question we have, it is from Shulabna Samanto. He asks, is life possible on the far side of the moon?
No, far side of moon is same as the conditions are same as what we see. It is not that we don't know what is there. There are satellites going around the moon. For example, we have our own thing, Chandrayaan, which is going around the moon all the time. So we can map everything about moon, so on. Of course, presence of water took a long time to people to identify it and so on. Those are different details. But condition on this side, what we see, and the other side, what we don't see from Earth, they are very similar. There is no dramatic difference between the geological condition from this side and that side. Biggest factor is there is no atmosphere on the moon. So if there is a water, very trace amount like which was found by Chandrayaan 1 and other missions, they are there, but they are not enough to sustain life. And if the underground there is something which our mission has, if I found, it would have been good, but unfortunately it could not land properly and find out the possibility of existence of more water on moon. So that some more time we have to wait for such discoveries.
So thank you, Professor Nayak. It was a very enthralling experience for each one of us listening to your lecture, and the questions are coming flooding in. But I am sure you are a very busy man, and so we'll put a stop here, and we'll expect you to be with us sometimes in future with similar topics. And on behalf of Birla Industrial and Technological Museum, as well as all the viewers present with us in this session, I thank you from the core of our heart, and we also thank the audience who were all present with us throughout this journey. Thank you, Professor Kumble. Thank you so much.
Okay, thank you for listening. And these are hard times. Many of you, like me, everybody is stuck at home and can't go out and so on. But keep up. This is all hard time. Sure to go one day, and we will be free as to walk around as before. Keep up with all the hard time, and you will be all right. Thank
Thank
you.
you, sir. Thank you, sir. Thank you. We close here.
Okay, thank you. I will close it and disconnect. Thank you.